In this video, we will discuss about the linear and non-linear systems. A system is said to be linear if it satisfies the superposition principle. Consider a system with inputs x1t, x2t and outputs y1t and y2t. For linearity, transform of a1 x1t plus a2 x2t is equals to a1 transform of x1t plus a2 multiplied by transform of x2t. For example, if we have a system whose response is given using this equation, y of t is equals to x square of t, like that is a system which has certain inputs x1t and the output is given as y1 of t. So considering the linearity, we will take the individual inputs. So for the individual inputs x1 of t, so what the system says that its response will be equals to x square t, like whatever the input is, it will just take the square of that input. So if the input is x1 of t, so the response will be of x1 square t. But if the input is x2t, then the response will be equals to x2 square t. So if you combine these two responses, so you can say that a1 x1 square t plus a2 x2 square t. But if you take the combined signal, like the combined signal is x1 of t and the combined signal is x2 of t, and then you check the response of the system. So the response means that whatever the inputs are, it will just take the square. So in our case, we have combined input x1 plus x2t. So the combined input, you will just take the response a1 x1t plus a2 x2t. So response means a1 x1t plus a2 x2t whole square. So this shows that it is not equal to the response when we have individual inputs. So for the combined signal, we have different response, while for the individual signals, we have a different response. So it shows that the system which has the response yt is equals to x square t is a non-linear system. While this system we have y of t is equals to x of t, so it is an assignment you can prove using the linearity function. So let me know that the system which is having this response is a linear or not, because I said it is a linear system. So you need to prove that it is a linear or a non-linear system. The second system is time variant and time invariant system. A system is said to be time variant if its input-output characteristics vary with time. Otherwise, it is a time invariant system. And the condition for time invariance is yn comma k is equals to yn minus k. Where how can you calculate yn comma k? So yn comma k is equals to transform of x n minus k. So x is your input. So for example, we have a system so whose response y of n is equals to x of n plus x of n minus k, and you need to check this condition for the time invariance yn comma k. So yn comma k is equals to transform of x n minus k. So it means that you are inserting the x n minus k here in x of n. So the answer is x n minus k plus x n minus 2 minus k. The second thing, you need to calculate the right hand side of this equation, which is yn minus k. So it means that you need to insert n minus k wherever the n is. Like in this equation, you need to insert n minus k. So like yn minus k is equals to x n minus k. So where n is n minus k minus 2, which is equals to x of n minus 2 minus k. So from these two equations, like the right side of yn comma k and the right side of yn minus k both are equal. So we can say that sides are equal, then the left side should be equal as well, like yn comma k, which is equals to yn minus k. So which fulfills this condition of time invariance. So that is why we can say that the system is time invariant system. We have another example, yn is equals to yn or x of n plus nx n minus 2. So that is the response of another system. So similarly, we will calculate the condition for the time invariance yn comma k, which is equals to transform of x n minus k. So which is equals to x of n minus k plus n x of n minus 2 minus k. So because we are inserting this n minus k with the time index of the signal, not in the amplitude or the scaling factor. So we are inserting inside the bracket. So that is why x of n minus k plus this n will not change, plus n x n minus k minus 2, which is equals to n minus 2 minus k. So similarly, we can calculate the right hand side, but in this case we are specially inserting n minus k instead of n. For this we are not inserting, we are calculating the transform, but for this we are inserting the value of n with n minus k. So similarly, we can say that okay, yn minus k is equals to x n minus k, like here instead of n we are writing n minus k, and here n again we are writing n minus k, because we are just inserting wherever the n is, we are just inserting n minus k. So that is why n minus k, x n minus 2 minus k. So from these two, right hand side of these two equation, we can say they are not equal. So it means that if the right hand sides are not equal, then the left hand sides are also not equal. So that is why we can say that this a function which has that response is a time variant system. The other is the time linear time variant LTV and the linear time invariant systems. A system is said to be LTV when it satisfies both linearity as well as time variance, while a system is said to be LTI when it satisfies both linearity and time invariance. So for example, we can consider the system with our response, and we have to check for the time invariance, we have to check this condition, and for the linearity we have to check the principle of the superposition. So for example, the response of a system is given by y of n is equals to n x square n. So if you perform the linearity function, so if you perform the linearity principle and take the response of the individual system, like individual inputs and the combined inputs, you will see that the individual inputs are not equals to the combined inputs. So that is why you can say that the system is non-linear. So I just write straightforward answer, but it is your assignment. You need to calculate one by one. The first step, that you need to calculate individual inputs for the input x1, for the input x2, and then you need to calculate the response for the combined input, and you will see that the answer of both are not equals. So that is why you can say the system is non-linear. And similarly, we can check for the time variancy, like we can check for the time invariance these two equations. So by checking these two functions, we can say that the right hand side on of the both conditions, like y comma yn comma k is not equals to yn minus k. So that is why the system is time variant.